Let me see. That should now be up. Yeah, and the live stream should be up any moment too. Let's hit refresh on the page, and indeed, I am live. Great. So, hi all. We are online. To everyone that's tuning in, it's always nice to hear where you're dialing in from. But hi, we are doing another live stream today, and this one will be about Optuna. Now, no, not that one, but shortcuts are always just a little bit annoying. But the tool that we were talking about is Optuna, and if I can just get the right shortcut going for, there we go, for the browser window that I wanted. But this is the thing that we're going to talk about, Optuna. It is a hyperparameter optimization framework. But it's also a little bit more than just that. So what I think is interesting is you're probably used to Scikit-learn, and when you think about hyperparameters, then you think about like regularization things. So like the alpha, like the C value in Ridge, or maximum depth in like these tree ensemble models and stuff. And you could wonder, well, how could a tool that is outside of Scikit-learn be helpful in that regard? And the short answer is that it is actually a little bit more general, which is both a good thing and a bad thing, depending on what you're interested in. It does a few things that I do like, though. So what I would like to do maybe is, I prepared a notebook, but what I'm going to do is I'm just going to show you what grid search and hyperparameter search is like in Scikit-learn, and then really contrast that to the way that Optuna does it, such that you can also maybe gauge if it is or is not going to be working out for you. Do ask tons of questions if you have them, though. What I'll just go ahead and do is I'll go ahead and refresh this notebook, and I'm just going to run these first few cells over here that do something of a hyperparameter grid search. So what am I doing here? I am importing this randomized CV object over here. And that is basically like a grid search. It's just that a grid search will literally try out all the values in a grid in hyperparameter space, and this will do the same thing, but it's going to do random sampling instead. So in this particular case, I'm going to be using this ridge model over here. I've got all these different values that I would like to try out. These values represent log values, by the way, but the main thing that's important is that these are different values for a parameter inside of ridge. And when you have a look at this randomized search thing over here, let's zoom in like one more time. But then you can see that, hey, I've got my model, that's the ridge regression. And there are these parameters that I'm interested in trying out. Those are these alphas. And this is then seen as kind of a distribution to sample from. That's the way that this is going to work. And the thinking here is that what I could do is I could say, well, there's lots of alphas that you could be trying, but this randomized search over here is only going to be trying 100 times. It's going to sample randomly from this list of items, so to say, and that's the way we're going to do our search. You can also use a SciPy distribution object here instead. That might be a little bit nicer depending on how you want to sample. But what you basically get here is this randomized search is still an estimator in Scikit-learn. So this is still an object that you can call fit predict on. It's just that when you call .fit, internally it's going to also loop over all these hyperparameters and it's going to try out a whole bunch of values. And it's doing that on your behalf, and you don't necessarily need to worry about the manual control there. Like that's all that stuff is done for you. And once you've trained this thing, then of course you've got this CV results property that's attached, and that is something that you can easily turn into a data frame. This is a dictionary of lists, by the way. That might be good to show, actually. Don't know if people ever were aware of this, but when you run grid search, or anything grid search like inside of Scikit-learn, you basically get this big dictionary out, and and there's lots of values. So you've got like the mean fits time, and like for the first experiment, for the second one, etc. But a list, like a dictionary with lists, can easily be turned into a data frame as well. So if you were to do something like import pandas as PD, you can just call pd.dataframe on it, and you can turn a list of dictionaries into a data frame, but you can also turn a dictionary of lists into a data frame quite easily. So that's something that just goes ahead and works. And it's not just inside of, you can use pandas for this, but you can also use polars for this. But the thing that I always find nice and convenient is if you have your cross-validation results, turning that into a data frame is just a very simple one-liner. And the moment that you've got your data frame, you can also use whatever plotting mechanism that you like. So I'm using Altair over here. And lo and behold, we do hyperparameter search here. It turns out if you want the mean test score to be kind of low, and this is negative mean tests, like this is, what is the test score here? The test score here is negative mean squared error, right? So then higher is better. So then somewhere over here would be fine, but somewhere over here would be bad. So fair enough. This is how you do grid search inside of Scikit-learn. Usually, it's just part of this randomized search CV object, and the only real thing that you do is you just call .fit, and then like a lot of stuff is handled on your behalf, so to say. Now, one interesting thing on that front, though, is there are different model selection methods. So you can do random search, you can do grid search, but there's also things like successive halving, if I'm not mistaken. Isn't that? Yeah. But like there are other methods to do model selection, so to say, and you have these CV objects. I need to look where. Oh, it's maybe in experimental. Yeah, experimental import. I don't know. Anyway, we'll Google that in a bit. But the main thing is that if you're going to do cross-validation search, you just have this module, and that's your mode of operating. You just call .fit, and all the sort of quote-unquote magic is handled internally. You could wonder, though, if the way you want to do grid search, if you maybe just want to have a little bit more control over that. So things you could wonder, right? Maybe I want to really fine-tune the way that I sample, and one way of going about that is, maybe I have a distribution that I want to sample from, and that is just something that SciPy does not support. Or maybe I want to do some pruning. One trick that you might want to do is you could say, well, there are these models that allow for the fit predict API, and I would like to fit predict all the systems in one sweep, and then throw the 10% worst ones away and only continue with the partial fit for the ones that are in the top 90% or something. This is kind of like successive halving. The idea is that you have your pool of candidates to try, and at some point you're just going to not give them compute anymore, and you're only going to really keep on training the ones that perform well. That can also be a way of doing grid search, right? But unless there is a CV object inside of Scikit-learn that does it just the way that you like, that is not something that you could easily sort of configure. You're going to have to write custom code for that. And this is also kind of the realm where Optuna sort of just takes a different approach. So where in Scikit-learn land, you would expect everything to be fit predictable, but Optuna can just kind of go ahead and say, well, no, we just do hyperparameters in super general. And really the way that Optuna likes to do it is the only thing you got to do is you just got to have some sort of an objective function. Like that's it. Like the only thing that I'm going to care about is you have just some sort of a function, and that some sort of a function is the thing that we're going to optimize over. And there's like a few abstractions here. Like there's this one big object that's known as a study. So you're interested in doing a study on a hyperparameter. You're interested in doing some sort of optimization thing. But, it's like one experiment. We're going to call that a study. There are some settings that you can pass to the study. Things like, hey, we want to minimize or we want to optimize. And you can attach databases. We'll see some of that later. But then the whole point is that this one study, you can give it something to optimize over. You can give it a number of trials, and that will just be the way that we do optimization here. So just to give a somewhat contrived, silly example, I have a function over here that's just a Python function. The value that comes out of this function is the thing I would like to be as high as possible or as low as possible, but that's some sort of score. Inside of that, this trial object, I can define that there's like an X parameter. This can be like your hyperparameter, so to say. That's something I can define inside of this one function. And then Optuna is clever enough to understand that, oh, there is this one variable, apparently. I have to sample that somehow. And the way that you sample, the way that you prune, the way that you store, like all of those things are basically configurable. So instead of giving you like a simple abstraction that will still allow you to just fit predict, Optuna is kind of a system that says, well, we assume you have the way your objective function in some sort of a Python function, and we just give you lots of tools to sort of work from there instead. So, like one thing about that I do think is just kind of nice is that does give you a lot of flexibility in general, right? Like you can really maybe tweak stuff, and what if you want to optimize stuff that's not necessarily scikit-learn based? You can kind of do stuff more easily here in Optuna maybe. But one question is, of course, like if we're interested in doing scikit-learn things, does Optuna offer something that scikit-learn doesn't? But hopefully we also understand that at this point, the two libraries are already like quite different. Like scikit-learn is really, we like pipelines, estimators, and components fit predict. And Optuna basically takes the attitude of, no, we have a function and we want to track different values of that function in something we like to call a study. That's kind of the difference. So if there's any questions about that, do let me know. As success. Oh, so someone is okay. Let's actually confirm that, because I think Ivan is telling me that there is a different import path. So from Scikit-learn experimental import. Oh, there's a function naming having search CV. Oh, that's how that works. Okay, so we can do this. Is that a? Oh, right. So we import it, and then that's probably going to add it to the module. So now I should be able to say from model selection and then success. No. Oh, it's having. There you go. Okay, sure. This is a pretty good. I'll talk about that technique in a whiteboard video, I think. But still, the rule in scikit-learn is that hey, if you want to do like grid search CV kind of stuff, you are gonna need some sort of a meta estimator, and that's kind of the scikit-learn way. That's basically the thinking, indeed. But anyway, we're gonna go to Optuna now. So okay, I've installed Optuna, and let's just run this. Like, okay, Optuna, I have a new objective. Some sort of trial goes in here. A trial represents like one run of something you're interested in optimizing. And I can tell the study to go ahead and optimize. And because this is a very cheap function to run, you can see that it's able to generate lots and lots of logs. Let's even zoom out a bit there. But you can clearly see like, hey, it does seem to be able to, there's trial 0 that finished with some sort of a value and some sort of an alpha parameter. The best at this point is trial 0 with a certain value. We try a bunch of other values over here, right? And then at some point we have this other trial 5 that has a value of 0. Like this is the lowest value so far, different alpha parameter. And now that is the one that has the best trial. And you can kind of see over time, like there's some trial that was best, but really it's trying out a whole bunch of alpha values. That's basically, pardon, what's happening under the hood here. So, so far so good. But then can we tweak this to do scikit-learn stuff? Because this is great. We can run whatever Python function. But if you're in scikit-learn land, you kind of want to run a specific trial for a machine learning model instead. So the way that Optuna kind of would like you to do that, or actually, let's first look at the stuff that that Optuna then gives you. So we're gonna just make those logs a bit smaller there. Sorry for the scrolling. Okay, I run the study. I tell the study to optimize, right? And then the study object, it does have properties that are now set because I've done a lot of training. And one thing that you get out is this thing called a best trial. That's basically this Python object that tells you what trial it was. It tells you some statistics, like when did we run this, from what distribution did we draw this sample, that stuff is available. You can also ask the study like, hey, what are the best parameters that you found so far? And if we have a look at the objective function, it's like x minus 2 to the square root of 2. So anything that's close to 2, that would be like a good score. And yeah, like it was able to get quite close. But what you can also do is you can just get every single, like all the stuff that it's done, like the results. You can get the values, start and end time, duration, and all that stuff also in a data frame form. So you can tell a study like, hey, those results, kind of like the CV results thing inside of scikit-learn, you can get some sort of data frame representation to go out. But let's now consider what this might look like if you do Optuna and then Scikit-learn. So that's something that I am doing down below here. So this is basically the same setup as before. Like, we're still gonna have a study object, and we're still gonna create the study object, and then we're gonna optimize it by using some sort of objective function, right? But the main thing that's now different is inside of this, I'm gonna be taking my ridge model over here. I'm gonna make one inside of this one function, and then I'm gonna use the cross-val score from Scikit-learn to just calculate me the cross-validation score instead. I'm doing cross-validation equal to 3 here to keep things fast. Probably want to have a higher number here. But basically, I still have a way to sample my alpha value and then come up with some sort of a score that tells me how good that alpha value was. It's just that I got to put my scikit-learn logic inside of here. And probably the thing that you want to do is you want to do something like cross underscore val underscore score here. That's probably the score that you're going to be most interested in, so to say. In this particular case, we have to change a few things, though. Like the scoring, because it's negative mean squared error. That's the standard of scikit-learn. Higher is better is what they try to go for. That also means that the direction that I've got here needs to be maximize. So instead of saying take the lowest value we're minimizing, I really got to be conscious about what direction to optimize for, because otherwise it's going to pick the wrong value. But another thing that I can also go ahead and do here, and let's call this thing ridge demo, just to make it like really, really clear that this is like a separate database. What I can also do is make sure that all the like all of these results that I'm sort of doing, that is actually stored in a proper database instead of just being kept in memory. And in this particular case, I'm going with SQLite, but one thing you can also do is point this to like a Postgres database or a MySQL database that's just in the cloud, in your network, in your company somewhere. And here you can also kind of see what's kind of nice about Optuna is if you're doing lots and lots of these experiments, you can actually store the results of those experiments somewhere as well. And that's something that Scikit-learn doesn't necessarily give you out of the box. It is something you can always add later, like the CV results. That's a data frame. You kind of send that to, some sort of backend. That's totally doable. But the fact that there's this abstraction inside of Optuna for like, oh no, like we actually have a study, right? And that's an object, and then that's going to be associated to some sort of storage place. That's sensible. But let's run this. So lots of machine learning models are being trained right now. Lots of different values for alpha are being trained right now, right? This thing has stopped running. I think I tried like 100 different values. And what I'm then able to do is I'm able to basically make the same chart that I had before. So I have my trials data frame that comes out of my study. And then, the exact same chart that I had before inside of Scikit-learn, that's now something I've got down here as well. So basic demo, if you're really just interested in getting the score just right, getting the same shape, getting the same chart is not necessarily the hardest thing. I do want to mention like a downside here, though, like something to just be kind of mindful of. And that is the fact that inside of Scikit-learn, you can quite easily say, well, I've got lots of these different metrics that I care about. And there's also like a classification report, and there's like some utilities that are super Scikit-learn specific. You can get them in Optuna as well, but that might require you to do just a little bit of extra work. This, of course, makes sense. Like, Optuna is not Scikit-learn, so if you want to do Scikit-learn specific stuff, you might need to do a little bit of extra work to get that working inside of Optuna. Just a thing to sort of observe here. There's also a question. Is this considered nested cross-validation? What I've seen in the docs is when we put the hyperparameter tuner into a CV score, or putting the CV into a hyperparameter tuner. I study things. If you could maybe expand on that. I'm not sure what this is. You mentioned this. It was about something earlier I said. This cross-val score over here, it is really just doing a single cross-validation run. So I have one model. I'm doing cross-validation equal to 3 over here. So that means that my data set is split up into 3 different segments. Each separate segment is going to be a test set once. That's the default setting here. And then, cross-val score will output a array of scores, and I'm taking the mean of that at the end over here. So I'm not really doing any searching for hyperparameters or anything like that. That would happen in the grid search CV object. But what Optuna is doing on my behalf is when I say, hey, suggest some sort of a floating value over here, this is going to be sampling over and over and over again, so to say. So that is also why this ridge model can, be associated with a score over here. So it might be good to also think about this like like a few extra things maybe. So as is, like, okay, this is what Optuna can do. We can do Scikit-learn kind of stuff. But is there also stuff that Optuna can kind of do that Scikit-learn doesn't? And then I'm especially thinking like, hey, what if I'm kind of on the outskirts of what Scikit-learn does and I need more of a custom function? Like, what are some features that Optuna offers that I might be able to use? Well, one thing that I did want to just mention, and this revolves, like, you have to write a bunch of extra code in order to do this. But one thing you could do is you can expand that objective function, and you can use some extra APIs that Optuna offers you to make your grid searches maybe a little bit more complete, to make it more of a model registry as well, instead of just storing hyperparameters. Maybe every single time when we train a new model, we also want to store that model next to the metrics, not just storing the metrics, but also the model itself next to it. So how would you do that? Well, again, inside of this objective function, I've got my trial, and that allows me to sort of have an alpha parameter over here. That's fine. Then next, what I could do is I could say, hey, here's a model. And again, I'm going to be calculating a score over here. Again, that's kind of fine. But here's like the extra tricky, like fun thing that you can do. Actually, to make this thing be proper, I'm just going to do a model that fit over here at the end. I'll explain why in a bit. But what I'm doing now is, before I'm running this objective function, I am making this artifacts folder over here. And I'm telling Optuna that I want to have, because it's an artifact, like from the artifact submodule in Optuna, you have an upload artifact, download artifact, and you've got a file system artifact store object. Basically, an artifact store is a place where you can send your pickles to, and Optuna has a abstraction for it, so you can just say, hey, here's an artifact store that's really just your file system. You can also use S3 or some cloud service for this, but I'm just going to use the file system locally. And then once I've got my score, what I can also do is like train my model on the entire data set. And right before I return the score, what I can do is I can just say, hey, let's dump that pickle file on disk just briefly now. And after that, I can upload that artifact to whatever artifact registry is associated with Optuna. So basically, it allows me to say, after the score is done, make sure you train the model on the entire data set. And then if we ever want to grab the model with the highest score, we can grab the model that saw all the data. And that is then something you can fetch later if you're interested. One thing that's a good practice when you do that is, I do think it's sensible that if you're going to upload an artifact and you get some sort of an artifact ID out, that you want that artifact ID to also be stored on that trial. It's a little bit silly if you have like a data set over here with lots of different hyperparameters and a score, but if you then couldn't associate that with the actual artifact you want to download later. So I think it's a kind of a good practice to be able to set some sort of an artifact ID, or there's also a way for you to store more than one score, by the way, if you want to not just measure the accuracy, but also precision and recall or F1 score. This is also like the way to do that. You can attach extra information, so to say. But an interesting thing now is if I were to run this study, it is going to take a little bit longer because, a bit more training that's happening under the hood, but it should still be done pretty quick. But if I were to like go over all the trials now, you can confirm that there's now this artifact ID in the user attributes. The system attributes also mentions the artifact ID, by the way, so that's fine. But the main thing that's different than before is we're able to add extra information here. That's also useful for like the F1 score and all that. But what you can then also do from here is you can say like, hey, I've got that study. that study has a best trial. That best trial has some user attributes. That's a dictionary. And I can just get the artifact ID from it. That's the artifact ID that's associated with the best trial. And the only thing I really need then in order to download it is to call this download artifact function. I can say, hey, here's my artifact store. Here's the artifact ID, and then save that into some sort of file path. And lo and behold, if I look this up correctly, the alpha value for the best trial, that was, let me do, yeah, I would expect there to be, did I not have some sort of a best score thing attached as well? Oh, I need to, params. There we go. Let's actually run these lines of code now. Okay, yeah, because there's a file. Okay, I need to remove that file. Fine. So I forgot to rerun the cells. That's why you're seeing this. But I'm going to remove the best model.scops file that's on disk right now. I'm going to run this cell. That will tell me that this is like that will allow me to load the best model that I've got so far. And if I were to compare that to study best trial or best params, right? So this, like, the best params found so far was this one, and when I load the rich model, then I can actually see that hyperparameter also being loaded up kind of nicely. So super cool. Like, you can add artifacts in Optuna. That's definitely kind of nice. And in Scikit-learn land, if you do lots of these cross validations, why would you store all those intermediate results in Scikit-learn land? That would definitely make less sense. But if you're doing something in Optuna, you have manual control over that. And that's kind of the main thing I'm on this show here. If you're doing Scikit-learn stuff, I don't know if you like really want to store every single model out there. Like, I don't know if, like, there might be use cases for it, but like let's say for every experiment, right? Like for every week that you're running, you want to train a new model, and that's part of your experimentation setup, and you want to be able to grab every model separately. That is something you can do. That's the main thing to just remember. The fact that this is a feature doesn't mean you always have to use it, but I did think it was at least worth mentioning that there is an artifacts submodule in Optuna. It definitely, it was pretty easy to interact with. The main thing you got to remember is that for every trial that you run, you do need to make sure that artifact ID is nicely stored. And I always like to do stuff like that manually. It's cool if the library does it on my behalf as well, but I'm always a little bit panicky when it comes to losing these IDs. Okay, some people are asking some questions now. You can also optimize over the dataset with Optuna. Yeah, that's what I just mentioned. See what works best. And yeah, able to select columns. That's also definitely kind of nice. So yeah, I hope people agree. This works. So far, so good. Not bad. But then let's talk about some stuff that Optuna can do. That's a little bit more manual, but like, you can do successive halving stuff inside of Optuna as well. But the abstraction you would use for this is something that Optuna likes to call pruning. So you're looking at a new objective function over here, and let's zoom in on that one because it's a bit different. So inside of this objective function, I'm still a trial goes in. I'm still doing stuff with alpha parameters, but now I'm saying let's use an SGD classifier. One thing that's interesting about an SGD classifier is that it runs via a mechanism called partial fit. The thinking here is that you can do stuff like, okay, I've got my data set. Let's train this algorithm for one epoch. And gradient update rule will happen. I have a better model. You can calculate some score. And then you can train another epoch. You can again calculate some score. But the way to maybe think about that is that from the perspective of Optuna, let's say that I've got trial 1. So trial 1, let's say I've also got trial 2 all the way up until trial 100. One thing I could do is I could run all of these trials for one epoch, right? So this is epoch 1 for trial 1. This is epoch 2 for trial... Sorry, epoch 1 for trial 2. And this is epoch 1 for trial 100. And you could maybe do a thing where you say, like, you know, if already at this point in time we can see that one item is just performing way less than the rest, maybe just stop that trial. Like, maybe we don't have to run like all of those epochs if somewhere along the training line there it's already clear it's not going to be the best one. And the thinking here is that by doing this, you should have less compute. Basically, you're only going to keep on assigning compute to to trials that actually seem like they might be winning. It's kind of like a genetic algorithm in a way. At some point, you can just say, hey, this candidate stops, and I want other candidates to flourish instead. This is called pruning. The thinking is that the way to implement that is you have some sort of a for loop inside of your system, and then you can call this trial report API. That's going to tell, let's say, the main process to go ahead and move on to another trial of Optuna to run another epoch, such that it could report some sort of intermediate value. But after doing the reporting, there is also the should prune call. And if whatever mechanism that you use for pruning decides that given the state of the entire study, we can stop chasing this objective function or this trial, then we can raise this trial pruned flag. That's the idea. That's sort of the API that they provide to you, which I thought was an interesting way of doing it. Like, why would you design it to be this way? Like, it feels kind of verbose that you have to report manually, then call should prune manually, and then raise a very specific error message, right? Like, why would you maybe do pruning this way? And the reason is that you can actually have multiple pruning algorithms. So one method of pruning is this thing called successive halving, but you've also got this other method of pruning, which is kind of like the median pruner, where the whole point is that we're just going to say bluntly, hey, are you performing better or worse than the median? And if so, if you're worse, we're going to stop investing in you. And there's a couple of trials for starting up, and there's a couple of warm-up steps, but you can kind of imagine a system where only if we see you improve and you're ahead of the class, then we're going to continue investing in you. And taking the median is just like one way of doing that. But Optuna comes with many different alternatives for this. What I think is cool about this is that this is like pretty darn flexible, right? You can have multiple strategies for your pruning, and you can also imagine like the way that you call the intermediate value and the should prune and all that. Like, that's something you can customize as well. The main downside is that if you want something custom, you also got to do the work. So in this particular case, the setup works kind of nicely because SGD classifier has a partial underscore fit method attached. Another way of thinking about it, and that's kind of what the successive halving system does inside of Scikit-learn. You can also say, well, let's train all of these things with like 10% of the data, and the ones that seem to perform well, let's keep them around, and then in the next round, give them just slightly more data. And then again, keep the ones that perform well, and then give them slightly more data, and maybe have like 5 candidates at the end, and they can train on the entire data set. And you can write the code for it, right? That's something you can do over here. But you can kind of hopefully see that the pruning, by not having that be so intertwined with the CV object and just giving you the building blocks to build it yourself, you are in the end a little bit more flexible. It's just that it does require you to write the code yourself. But you can do pretty flexible things with this pruning mechanism inside of Optuna. Like, it's a bit of a different ballgame than the way that Scikit-learn would do it, because Scikit-learn would do all of it for you. But again, customization is appropriate. Like, that can be useful in some situations. There's a couple of questions, so I'll answer those questions first, and then we're going to move on to like a final thing I did want to show that Optuna does, which I thought was pretty cute too. Can Optuna be used for hyperparameter optimization or parameter optimization as well? The answer is yes. It's the main use case for it, so that's indeed fine. What's the difference between Optuna and genetic algorithms? I think you should look at Optuna as a framework that allows you to write genetic algorithms to do hyperparameter optimization. But Optuna just gives you building blocks to write your own custom way of doing hyper optimization. Like that's the way I would look at it. So there's a nice abstraction for like storing your artifacts and storing your metrics and the way you do pruning and the way you do search. There's like all sorts of building blocks for it. And theoretically, you could also turn it into a genetic algorithm if you want. But I didn't see genetic algorithms inside of Optuna. We'll get to that in a bit because there's a downside with related to how it does parallelism that we should maybe want to talk about there. Optuna is an optimization to the frame. Okay, so people are answering the question already. Should maybe look further, but fine. Yes, seems like no need for me to answer more questions. So what was I prepared this morning? What was this bit about? Yeah, and so this is just to show the logs. So here you can definitely see like, hey, there's like a couple of trials that are running, right? But then it turns out that a couple of trials that follow, they don't really run, they just get pruned. And then at some point, there's a couple of trials that still perform quite well. But a lot of these trials get pruned. Like that's the logs that I want to sort of show you here. Okay, so we have pruning. That's something that can help us reduce the computational cost. But there's an extra thing that we can do as well. And this was a fun one to read. Like I did think that this was kind of an interesting way of doing it. And this is the topic of sampling. So I've updated my objective function over here to be slightly different. I have an x value, a y value, a z value, and they should all be close to 0. That's the thing I'm trying to optimize for. These are all like floats, right? But okay, these are floats. That's great. If you're going to do random search, the way you would really do it is you would literally take your interval, right? And you would just really you would sample randomly from all over the place, basically. But you can't imagine, like, if we're going to do 500 trials, and if it just turns out some of the better hyperparameters, you know, maybe they're a little bit more on one side of the full spectrum to search in, and maybe we should sample more in regions that are more interesting at some point. It's kind of like the like active learning way of thinking about it. If there's regions that are more likely to have the golden coin, we should look more in that region as opposed to like sampling randomly all the time, so to say. So that's where these samplers come in. These samplers represent just a couple of techniques that allow you to sample more intelligently as you do another trial, so to say. And the hope is, of course, that every time that you do a trial, it's either going to be very clever in exploring or it's going to be very clever in exploiting. That's kind of the hope here. There's minus 10 over here and there's plus 10 over here. And let's say we do lots and lots of samples. And let's then pretend that the top 10 performing samples, they are all over here, let's say. And then all the other samples, let's just pretend that they are sampled homogeneously so far. So, you know, these might be all the samples, but we've got this one region over here that just performs better than the rest. Okay, and let's actually make it a little bit more complex. Let's also say that it's there's more density here than over here, and let's also maybe do that for some places over here. It might be that some places are more dense, let's say. Well, what we could do is we could do something like, oh, let's just train some sort of a Gaussian, like just do a normal distribution on it. We can sort of fit a hill over here, and we can kind of fit a hill over there, and that tells us something about the likelihood. Like if you train a Gaussian, you can also sample, and if we try to have a Gaussian fit over the region where apparently we get like lots of good shapes, then maybe what we could do is we could just fit a Gaussian on the top 10% and just sample from there forever. And you could do that, but that you do get like stuck in a local optimum maybe. Like that's the thing you want to maybe watch out for. Like you can keep on sampling forever in like one region because your first few trials suggest you should go there. But maybe what you should do instead is you to say, well, I want to sample mostly from here, just not all the time. And also, maybe just a single Gaussian hill is not going to fit. So what they do is they fit a Gaussian mixture model. So there's some sort of a, let me use the coloring right as well. So they use some sort of a Gaussian mixture model to fit something over here, right? So that's a distribution I have for that region over there. And because it's a Gaussian mixture, I can kind of have a mixture as well for all the other points. And it's probably going to look something like this, right? And if I'm going to do this properly, I should also just keep on drawing the green line. It looks something like this, right? Not the best drawing, but good enough. And the way that this TPE sampler works is it's basically just saying, let's have a warm-up period, let's say 100. And during that time, we're just going to get our green and black dot samples. And after that, we're going to fit these Gaussian mixtures. And we're going to look at the ratio of this good distribution over this average distribution. And it is just really going to favor data points for which this ratio is just high. So we're still going to sometimes sample from the black region. It's just going to be more likely that we're going to sample from the region where the green is higher than the black, so to say. That's the thing that we're going to go for. And because of the way that this is set up, if in this region over here, it is just super duper likely you're going to get a bad result, then what's below here is going to be big. And then that's going to be less favorable, but never zero. Like that's kind of the goal here. This is called the TPE sampler, and this is something that Optuna actually has as a default, if I read it correctly this morning. And I thought it was actually kind of interesting because you would kind of expect a lot of this stuff to just do the random sampler thing, but there's definitely like a two-phase situation happening in this one. So what I figured I would do just as a quick demo, let's just run two studies on this objective. One is going to use a TPE sampler, one is just going to use the random sampler. And to make it explicit, this TPE sampler has a startup trial of 50 studies. I'm so sorry. We're going to take 50 trials, I should say, at the start of this study, and then it's going to kick in, and then it's going to do sampling differently. So I ran this morning, and I was actually able to get like a pretty nice chart out that really demonstrates how it works, which is what you're seeing over here. Let's zoom out a bit. So on the x-axis over here, this is the number of trials that I'm running. And on the y-axis here, you see the value that came out of the system. And we're minimizing here, and the smallest value you can get is 0. And as I pointed out just now, this TPE sampler over here has a startup period of 500 trials. And you can really clearly see this orange line over here, that's the TPE sampler. And this blue line over here, that's the normal like random sampler. And you can really clearly see that they seem to be kind of the same distribution in the beginning. But boom, at some point we hit the 50 mark, and the TPE sampler samples like way more points from the interesting region. That's something you can clearly see over here. We still get some high values now and again, but in this particular like super easy demo, you can see the effect like, okay, there's a warm-up period, and after that we are, like here we're still allowing ourselves to explore the space a bit. But after that, we're going to go full-on exploit. Like, we're going to try to sample from regions that have high-scoring hyperparameters, mostly. And I thought this was kind of interesting, too, because you can kind of imagine Optuna allows you to write custom samplers if you're interested in it. Optuna has some Bayesian optimization things as well. So there's definitely, like, intelligent things that you can configure. And I can also imagine, depending on the type of search that you want to do, if you're into this kind of stuff, Optuna just has way more bells and whistles and levers and things that you can customize in Scikit-learn, I think. You can always write your own custom Scikit-learn estimator, of course. Like, you could also look at that as a way to really get custom. But just the fact that you're able to do this, I thought was, kind of a nice touch. If you've got a good reason to do something really, really custom, you get some good building blocks. And I thought this was kind of like an interesting demo in that sense. And like a final thing on this particular demo, there is, so here you go. There is also like some visualizations you can do. So there's like, you can plot the parallel coordinates, and you can see that the standard study samples from all over the place. And if you take the study that uses the TPE thing, then you can see that we sample a lot closer to 0, which I thought was also kind of an interesting thing. But yeah, like these are the building blocks that Optuna gives you. So I hope that people sort of can look at that and appreciate that some stuff is definitely different. Like if you use Optuna vanilla, you're going to be writing this objective function and you're going to add settings to your study, and like that's the way you're going to work. But this will be kind of the time where I can also imagine you wonder like, okay, should I use Optuna forever? Like what's the deal here? And I will say, like, I did find like one downside that I do want to make you aware of. That's the shortcut. And that downside is related to the parallel programming that they do. So I had a look at their docs, like how can you do parallelization inside of Optuna? Because everything that we've done so far is serial. We need to do the first 50 trials in order to know where to look in the next few, and that's something you can't do in parallel. It's like it has to be sequential, and everything that I've shown you so far is something that is sequential. Like there's no parallelization happening whatsoever. Now, what you could do is you could say, look, there's this centralized storage place, there's this database, and you can configure things that say like, okay, if there are already 100 trials in that database for this study, stop sampling. But if you want to study among multiple nodes and processes, the way that they seem to tell you to do it is to just call Python in one process and to call the Python script in another process. Like you basically have two terminal windows that run the same stuff at the same time. That seems to be the main abstraction that they give you. That's fine, right? That kind of works. But one thing I really like about Scikit-learn is that Scikit-learn integrates with joblib, and there's just this one setting that you can set that says, okay, do this now, but in parallel, and it just takes care of the rest for you. The fact that that's not necessarily super duper easy in Optuna is a bit of a downside, but at the same time, I can also imagine that there might be like plugins for parallel programming backends in conjunction with Optuna. So one thing I did also notice, so there is also an integration, if I recall correctly. Integration. Yep, so there's a couple, yeah, there we go. So there are a couple of these integrations on different backends that you can go ahead and use. One I noticed is this Scikit-learn one. So there is a Scikit-learn, and there's this Optuna integration library, and there is this Optuna search CV object. New tab. There we go. So what they do have something of an integration with Scikit-learn directly. The thinking is that you're still going to use Scikit-learn, but then you are going to use Optuna to store all your results. So if you have your server somewhere that's set up for Optuna, I think you can use this to plug into the big ecosystem. There are also some flags for like, do you want to enable pruning and the goods. And one nice thing, I've not had the time to actually give this a spin, but one thing that seems nice about this approach is that if you want to use Optuna together with Scikit-learn, this object does still offer you to do end jobs over here, which suggests to me that you can actually use this to get the joblib feature for parallelism in conjunction with Optuna for Scikit-learn. Like that, like if you're going to explore Scikit-learn and Optuna together, this is the thing to check out. Another nice thing about doing it this way is you get the standard Scikit-learn stuff with it. So I believe, yeah, you can set the CV, but I think you can also set, I would imagine, yeah, there you go. You can also set the scoring. So that means that you can also reuse all the metrics that Scikit-learn has and get a report on that. So that's also good. So yeah, and you can pass an Optuna study object in here. So like, you know, if the stuff that you see here in Optuna seems nice, this will be the next step to kind of explore. Like I was a little bit more interested in exploring Optuna like on its own. Like, can I also use it outside of Scikit-learn? And my simple conclusion seems to be that it just offers a lot of sensible building blocks, but you are also required to write a little bit more code yourself. That's I guess the way to look at Optuna. It also seems to be that Robert is saying nice things about this particular object, which is nice. Yeah, because one thing I wonder, Robert, if you're listening, by the way, like one thing I wonder, how would I specify if I want to use random search or grid search via this object? Like I see that I can pass a study in here, and that study could contain that information on how I sample. Yeah, okay, that's probably the way that you do it. You just pass the study in here, and as we saw over here inside of the Jupyter notebook, the study can have the sampler, and then yeah, okay, that can be a fair way of doing it actually. Okay, that's actually kind of nice. That's actually kind of nice. But yeah, this is Optuna. The way to think about it is it just gives you some building blocks to do hyperparameter search, but also in such a way that you don't necessarily have to use scikit-learn. Like the stuff that I'm showing here, hopefully it's also clear that you can just swap out whatever scikit-learn code you have here with PyTorch code or whatever library that you've got or whatever custom Python function that you've got. Optuna does not necessarily care. As long as some sort of value number goes out, you're good. So yeah, stuff to like is a simple thing. If you want to upgrade some scikit-learn things with regards to where your data is stored, and if you have like your own hyperparameter storage data warehousey thing, that's definitely something you can build with Optuna. So um, it doesn't have enough features for me to sort of go like, oh my god, you should always use Optuna. But it does offer enough features that make me go like, okay, if you've got like a Friday at your company where you want to explore a new tool, Optuna does seem to be like it won't feel like wasted time. There are some interesting ideas in here. It's just that you are going to have to write a bunch of custom code, but it is also going to allow you to customize. Like that's the abstraction they've chosen for here, which is fair, totally fair. Yeah, so that's the thing I wanted to show, at least for this week. Just to check if there are any questions. If not, then I can maybe make a few mini announcements. But this is the main thing I just quickly wanted to show for this week, at least. So just to check if there's any questions coming in. It doesn't seem like it. Okay, then on to the announcement stuff. If you have been paying attention on our social media channels and if you've been on our Discord, you probably have noticed that we have started our certification program. It is. Oh wait. Someone is asking like, what optimization framework makes you go definitely use this? Depends a bit on the problem. If I were to do traveling salesman kind of stuff, I would just use OR tools just because I've used it in the past and it kind of works. If I'm doing convex optimization stuff, then I do CVXPy. And if I'm doing hyperparameter search, then I so far usually like to use the framework, like the machine learning framework that I'm using. That's the main thing I've done so far. My feeling for Optuna is it definitely feels like it has a cool use case. But it's a use case that I don't necessarily have. Like most of the benchmarks that I run, I can kind of run on my own, and I don't run that in a team. Actually, that might be a good thing to actually point out. It's actually like pretty good question, actually. Like I think a use case where Optuna can really shine is actually in a situation where you've got a team. Because in a situation of a team, you don't want to you don't want to have the situation where there's just some person behind a laptop, and the person behind the laptop is going, "Yes, I have the best hyperparameter." And the only way to sort of figure out if that's accurate is if your colleagues are willing to walk over next to you and look at your laptop screen. Like in Teams, what you preferably want to have is like you run your experiment on some sort of compute hardware somewhere in the cloud, like some VM, and automatically the results of that grid search get stored in some central place, like a database. And you want your artifacts to also be stored in a central place, like S3. And for the team situation, okay, and now Optuna suddenly brings a lot to the table, right? Or a lot more, I should say. And you've got like the cloud providers, the Vertex AIs of the world, and like Amazon SageMaker probably also has like some abstraction for this, right? That's all fine, but like this is where Optuna is kind of a nice open source framework that could maybe facilitate a team need. It's just that at me as a person, like a lot of the stuff that I do in the end is benchmarks for either the open source team or for live streams and stuff. I don't necessarily store my things in a database because the next week I usually move on to a whole new different experiment that is also like kind of throwaway. Like the results matter, but not necessarily the hyperparameters. So yeah, like I do want to maybe mention that before I actually log off. Like if you're in a team scenario, then hey, this Optuna thing might actually be like super duper neat. And if you are in a situation where just the very nature of the machine learning thing you're trying to do, you have a lot of custom stuff that you want to keep track of, and then those are sort of the situations where Optuna would really really work well. It's yeah, and also like in my mind, when someone asks, "Hey, Vincent, what optimization tools do you use?" My operations research mind immediately goes on because that's my like academic background. It is a bit of a different field than what we're doing here. It's also like something that's maybe worth mentioning. Um, that said, like one thing you could do that is kind of cute, maybe, right? Like one thing you could also do is you could maybe play around this weekend and like see if you can use Optuna to write a genetic algorithm. That could be kind of fun. What you could kind of do is you could say, well, I've got these candidates. Let's make that like let's make that a proper list. So I've got like candidate 1, candidate 2, candidate 100 or something like that. And you just do that in a single trial. And then once the trial is done, you're going to go like, okay, this candidate was part of the worst 50%, and these candidates were part of the best 50% or something. And then I'm going to start a new trial. And what I'm going to do is I'm going to combine new candidates by taking candidates that worked quite well, and they get to sort of quote unquote produce offspring, as genetic algorithm people like to say. So you've kind of got like evolution step 1, where some candidates survive and some don't. I don't know if this is going to be much more effective than just using a TPE sampler, to be honest. But the fact that you are able to build that, you get the building blocks to build that, and you're still able to write Python code if you want to as well. That said, like I guess like as I'm hearing myself talk, like one thing I also just want to maybe mention, like if you're really interested in making like if you want to get this to work inside of Scikit-learn, like nothing is stopping you from like building some sort of a genetic CV object as well, right? Like that's also something you can just write yourself. Could be a fun exercise. Like you just build your own genetic CV. Like if you end up building this, like go to the Scikit Lego thing on GitHub and let me know, because it might be a fun thing to add to the library. You are always welcome to like build your own custom estimators as well, right? Like you can also, that's also a thing you can do inside of Scikit-learn. If a building block is missing inside of Scikit-learn, Scikit-learn makes it easy for you to build your own still. You just have to write Python code for it. Yeah, so Ray Tune is also a thing that's actually somewhat related. Let's go out of full screen here. I said, shortcuts with many devices are just a bit annoying. But yeah, like there is this library called Ray. Oh, not this one. Ray Python. Yeah, it's like a compute frameworky thing. The thing that Ray does though is it's a little bit more. It provides you a compute layer that you can run your things on. But if I am not mistaken, joblib that Scikit-learn builds on already supports Ray, if I'm not mistaken. Let's distributed Scikit-learn on the Ray docs. Yeah, there you go. Like the thing is like joblib already supports Ray as a backend. So if you want to use like random search on top of Ray, you can just use this with joblib parallel backend decorator, and then just call search.fit, and that should go ahead and run on a Ray cluster. So if you're interested in doing like Ray compute clusters with grid search, that is something that Scikit-learn actually kind of supports right out of the box. I don't know to what extent Optuna integrates with it. You would have to maybe check the docs on that one yourself, but I do want to maybe mention like you can pick different backends for joblib, and it is my impression that the Ray backend is actually somewhat popular. So if that's a thing you're interested in, definitely check that. Like give that a look. Yeah, I think this is mainly everything I wanted to say. So in terms of announcements, we are doing more and more certifications now. So we had the sort of level 1 certification program went out last week, I think. Level 2 went out this week. My impression is that level 3 will be out quote unquote soon. If you're interested in getting like officially Scikit-learn certified and you have questions about it, do come to the Discord. One thing that I might do in the short future is I might actually do a live stream or two that might help you prepare for certification. I still need to figure out what might be good content for that, but like I can't imagine that if people are interested in maybe passing these tests, that having some sort of a live stream where I can answer questions, that might also be like a good way to spend time. Next week, however, I'm not going to do that because there's a reason why I was checking out Optuna this week. It turned out that there's this library called, or this sort of forest of time series libraries that likes to refer to itself as the Nixtla-verse. And Nixtla is a company that makes tools for time series. It's not 100% Scikit-learn compatible, although it mostly certainly is. And they have a couple of time series tools that I was very eager to look at. It's just that if you do a grid search in Nixtla, Nixtla is actually built on top of Optuna. So in an attempt to understand Nixtla, I found myself in a situation where I actually had to understand Optuna first before I could understand this tool. So the reason we're doing Optuna this week is because I want to talk about this tool, and Optuna is a prerequisite for it. Time well spent nonetheless, but that's actually the reason why I wanted to do Optuna this week. Next week, we are going to dive into this Nixtla-verse a bit more. And in particular, we're going to look at the ML forecast library. My impression is that this just offers a couple of extra tools on top of Scikit-learn and stuff that you can kind of use together with Scikit-learn. But some tools here should address some of the challenges in time series land, and that's something that might be fun to look at. If you like, I might also be able to dive into Optuna just a little bit more for time series with that in mind, but this will be the thing that I'm interested in discussing next week. The weeks that follow will probably have more content about getting certified and all that, or stuff that's like some content that might be related to some of the stuff that we test for. Let me put it that way. I hope this is interesting. Definitely join the Discord if you haven't already. Discord.probable.ai. You'll be able to find me and my colleagues there as well. Definitely thanks for listening, and yeah, see you.